what is an angle? That's what we're going to try to answer here, along with look at some theorems that have to do with angles. So first of all, what is an angle? We all know if I give you something like this, two lines, can we find the angle? And your first gut instinct might be to take out a protractor. So we could use a protractor to measure that angle, right? How would we do that? Well, we know we have to align the bottom of the protractor with that, sort of with that. We need to put the corner of the angle sort of in this center point here. Let's see if we can do this. And then we can read off the angle, right? Let's see if we can do this. It's a little bit tricky, probably a little bit easier in person than on a computer. So what angle is this? So if we look at the protractor, we look here, we look here, what angle measure does it come out to? You might be tempted to say, oh, it's like between 110 and 120, which is 115. Is that right? No, it's not. There's actually two sets of numbers we need to look at for a protractor. And this angle here, you should know, is less than 90 degrees, right? Because a 90-degree angle is a right angle. It looks like that. So we have to actually read off the smaller numbers here. So this is more like 65. It's between 60 and 70. So that's the angle here. So that's how we would use a protractor. Now I'm using a program that I can actually construct the angle, and it would tell us what the angle is. So I'm just going to make that right now, and the angle is 65 degrees. There we go. I'm actually going to hide this little symbol here. Let's just open our settings. I'm just going to hide that symbol just so we see the value. There we go, just to make it a little bit clearer to see. So 65 degrees. So you were right, it was 65 degrees what we measured using the protractor. Now I have a question for you. If I make these line segments longer or shorter, is that going to change the angle? If I extend this or make it shorter, is it going to change the angle? Well, let's try it. If I make this longer, is the angle going to be bigger? No, look, the angle stays the same size, right? Same thing if I change this one. Is that going to change the size of the angle? No, it doesn't matter how long they are. So angles actually have nothing to do with side lengths. They just have to do with sort of the opening in that corner. I can change the angle here by making it smaller or larger, like this. So we can see that the angle gets smaller. That's 21 degrees. It's a tiny little angle. And it gets bigger, 80 degrees, 79, 80 degrees. And we also know if we go to 90 degrees, oh, can I go to 90 exactly? Oh, it's not going to let me go. There you go, 90 degrees. We call that a right angle, right? And that's sort of the angle right in the middle of a protractor. So remember, that's something to keep in mind. It doesn't matter the length of the sides for an angle. The angle is just how much open space there is in that corner, how big the opening is basically, right? Now, so that's 90 degrees. If we continue, we can go all the way up to 180 degrees. And let me actually change that. I'm going to change some settings here on this. Let's go between 0 and 360. There we go. So this angle is 180 degrees, right? We've opened that angle up all the way to 180 degrees. Now, what do you notice about 180 degrees? It forms a straight line, right? It's like along the bottom of this protractor. So when we say we do 180 degrees, it's like you go all the way, sort of halfway around, right? And it forms a straight line. So that's important as well. I can continue going here, right? What will I get if I go all the way around to the starting point? What's it going to be? Well, you can see I can't really get it to be exactly that, but oh, there it is. 360 degrees. So a full circle is 360 degrees, a full opening. If I open this angle so much that it goes all the way around, that's 360 degrees. So these are some key numbers you got to remember. You got to remember that, first of all, the angle gets bigger as we open up from 0. 90 degrees is called a right angle. 180 degrees forms a straight line, and 360 degrees is a whole circle. You'll notice 180 is just half of 360, right? That's why that works. Okay, so that's what an angle is. And remember, it doesn't matter how long the side lengths are. Actually, it doesn't even matter. I can put this in a triangle, right? I can say that that's an angle in a triangle, for example. Even if I change these, the lengths of these, it's not changing that interior angle. I could change this, right? But it doesn't matter. An angle is still the same thing whether it's in a triangle, whether it's in any shape, or it's just by itself. Okay, so let's go over here. So first of all, we have to look at something like this. If I have two angles like this, that sort of, when you put them beside each other, so actually let me go down here. When I put these two angles beside each other, they form a straight line. First of all, these two angles are called supplementary angles. Angles are called supplementary angles whenever they form a straight line, when you put them back to back like this. What should those two angles add up to if we put them like that? Well, you can try it. We can do on our calculators 103 plus 77. What does that give you? You should see that it gives you 180. I can change that, right? So I can go to like that. Let's try it again. What's 133 plus 47? Well, again, that should add up to 180. Does that make sense? Well, I'm going to actually go back over here and grab this protractor and bring it over here. Does it make sense? Well, if I put the one end of the protractor here, one end of the protractor here, I line it up. Does it make sense that those angles add up to 180? Yeah, it does, because remember what we said, 180 degrees is like half a circle. It's halfway around, or it forms a straight line. So whenever angles do this, they're called supplementary angles. Okay, two angles that add up to 180, basically. Okay? All right, that's one type of angle, and that's called the supplementary angle theorem, actually. And that's useful. You'll see that in the next part of the lesson. The next thing we got is if we have two angles here, and if we put them back to back, like that, what do you notice they form? It's actually a right angle. It's a little bit hard to see, so let's grab that protractor again. Bring that over here. Let's see. If I put that protractor there, right in the corner, move that there, move that there. Let's see if I can do this nicely. There you go. See? So those two angles beside each other added up forms a 90-degree angle, a right angle. So if you do this and the two angles add up to 90 degrees, we call them complementary angles. So you can see no matter what I put, so if I put 40 and 50, if we add them together make 90, those are complementary angles. If I move this over here and do 56 and 34, those add up to 90, my bad. So those are complementary angles. Or even if I make this one go down here to like 6 degrees, so the tiny little angle in here is 6 degrees and this one's 84 degrees, those add up to 90, so those are also complementary angles. One more thing. If we have angles that are across from each other, like you have two lines that are intersecting and you have angles that are across from each other, those two angles are going to be the same. No matter what, they're going to be the same. They are called opposite angles because they're opposite each other, right? It makes sense. And if you're confused about that, you can think about just like looking in a mirror, right? This is just a mirror reflection on the other side. So the angles opposite each other are going to be equal. So this is called opposite angles. One other thing, so if we have opposite angles, two angles like this, all right, so these two angles, these two 68 degrees are here. Oops, let me move that over here. These two opposite angles are here. Could we actually figure out what these other two angles here? Well, I show you here that they're going to be 112 and 112. And the trick is that if you look at it, if I break them up like this, what do you notice about these two pairs of angles? So these two angles here and these two angles here. That should look like another one of our cases that we've already talked about, right? If we go all the way back, if I zoom on and go all the way back over here, that looks like this, supplementary angles, right? So when we have angles sort of like this in sort of two lines crossing, we know that there's going to be supplementary angles beside each other, right? And I could actually do the same thing with these two angles, right? If I put these two angles here and these two angles here, these also would be supplementary angles because these add up to 180 and these add up to 180. What's the full circle going to add up to? Well, we know the angle in a full circle is going to be 360 degrees. So you can check that. If we added up all four of these angles, we should get 360 degrees. And it doesn't actually matter what those angles are. as long as if you put them together, they form a full circle, that's going to equal 360 degrees. So just to refresh our memories on everything we talked about right here, there are three types of angles you need to know. The first one is supplementary angles, and those are angles that add up to 180 degrees. The next is complementary angles, and those are angles that add up to 90 degrees. And then there are opposite angles, and opposite angles are just equal to each other.